Good day, math buddies! Sir Sherwin here, your math instructor. For today's video, we will be discussing all about exponents and its properties. Of course, we will be guided with these objectives. First, we will define an exponent. We will also state the different laws of exponents and simplify expressions with positive, negative, and zero integral exponents. But before that, let's define first an exponent. It is a number which tells how many times a number is to be multiplied by itself, while base is defined as the number that is to be multiplied. Let's have an example. X raised to the fifth power. Here, 5 is our exponent and x is the base. It is read as x to the fifth power, where we multiplied x 5 times by itself. Another example. Quantity x plus 1 squared. In this certain expression, 2 is our exponent and x plus 1 is our base. This means this expression can be written as quantity x plus 1 times quantity x plus 1. Let's also discuss the different laws of exponents. First, product of powers. For any real number a and positive integers m and n, a raised to m times a raised to n is equal to a raised to m plus n. For example, b squared times b to the sixth power. In this case, we have the same base, which is b. All we need to do is to add their exponents. That means we will be adding 2 and 6. The sum is 8. Therefore, the simplified expression is b to the 8th power. Another example. 3 cubed times 3 squared. Again, we have the same base, which is 3. In this case, we will try to add their exponents 3 and 2. So the sum of 3 and 2 is 5. Therefore, the expression is 3 to the fifth power. But of course, we can simplify this one because we can multiply 3 by itself 5 times. The result would be 243. Let's have the third example. X to the fifth y z cubed times x squared y raised to 7th power z. And this certain expression, all we need to do is to add the exponents of the same base. Here, x has exponents 5 and 2, y has exponents 1 and 7, and z has an exponents 3 and 1. So therefore, the simplified expression becomes x to the 7th, y to the 8th power, and z to the 4th power. Power of a power. For any real number a and positive integers m and n, quantity of a raised to m raised to n is equal to a raised to the product of m and n. For examples, quantity of b squared raised to the 6th power. All we need to do is to multiply our exponents 2 and 6. The simplified form becomes b to the 12th power. Second, quantity of 3 cubed squared. Again, all we need to do is to multiply our exponents 3 and 2. That is 3 to the 6th power. And of course, we can simplify this one by multiplying 3 by itself 6 times. And that is equal to 729. Let's have the third one. Quantity of x to the fifth squared. Again, all we need to do is to multiply our exponents 5 and 2. The simplified form becomes x to the 10th power. So in power of a power, notice that we write the base and multiply the exponents. Let us have the third one. Power of a product. For any real number a and b and positive integer n, quantity ab raised to n is equal to a raised to n, b raised to n. For examples, quantity xy raised to the 6th power can be simplified as x to the 6th, y to the 6th power. Another one. Quantity 2m squared. This expression can be written as 2 squared m squared, and it can be simplified as 4m squared. Third example, quantity 4xy squared. This expression can be written as 4 squared x squared y squared, and can be simplified as 16x squared y squared. In a power of a product, remember to raise each factor inside the parentheses to the given power. Power of a monomial. For any real number a and b and positive integers m, n, and p, quantity a raised to m, b raised to n raised to the p power, that is equal to a raised to the product of mp and b raised to the product of n, p. For examples, quantity 2, x to the 6th, y to the 4th power, raised to the 3rd power. Here, in order for us to simplify the given expression, all we need to do is to multiply the exponent outside the grouping symbol to every exponents inside our grouping symbol. In this case, we will have 2 raised to 1 times 3, x raised to 6 times 3, y raised to 4 times 3. Then, let us simplify. 2 cube x to the 18th power, y to the 12th power. Therefore, our final answer would be 8x to the 18th power, y to the 12th power. Another one. Quantity m squared n to the 5th power raised to the 6th power. Again, all we need to do is to multiply the exponent outside our grouping symbol to every exponent inside our parentheses. This means m raised to 2 times 6, n raised to 5 times 6. The simplified expression becomes m to the 12th n to the 30th power. Another one. Quantity a cubed b to the 7th squared. Again, all we need to do is to multiply the exponent outside the grouping symbol to every exponent inside our parentheses. This will lead us to a raised to 3 times 2, b raised to 7 times 2. The simplified form becomes a raised to the 6th power, b to the 14th power. Quotient of powers. For all integers m and n and any non-zero number a raised to m over a raised to n, that is equal to a raised to m minus n, where a is not equal to 0. Examples. A raised to 7th over a cubed. So all we need to do is to subtract the exponents in the numerator to the exponents in the denominator. So a raised to 7 minus 3 will lead us to a final answer, which is a to the 4th power. Another one. 15x to the 5th over 5x squared. In this case, we will divide 15 and 5 and subtract the exponents in the numerator to the exponents found in the denominator, provided that we have the same base. 15 divided by 5, that is 3, and x to the 5th minus 2 is x cubed. Therefore, final answer becomes 3x cubed. Power of a fraction. Quantity a over b raised to m is equal to a raised to m over b raised to m, where b is not equal to 0 and m is a positive integer. For examples, quantity x over y raised to the 5th power. All we need to do is to multiply 5 to every exponents found in our fraction. In this case, this expression can be written as x to the 5th over y to the 5th power. Another one, quantity 2 over 3 raised to the 3rd power. In this case, the simplified expression becomes 2 cubed over 3 cubed and can be written as 8 over 27. Just remember to raise all factors of both numerator and denominator to the given powers for us to simplify the given expression. Let us also discuss zero exponent. Remember, for any non-zero number a raised to 0 is equal to 1. This is a proof. How did we come up with 1 as the value of a raised to 0? So, if we will have, for example, a raised to 7 over a raised to 7, applying the quotient of powers, all we need to do is to subtract the exponent in the numerator by the exponent in the denominator. This leads us to a raised to 7 minus 7. Here, the difference of 7 minus 7 is 0. So therefore, our result is a raised to 0. On the other hand, if we will utilize the concept of a number divided by itself, the result is equal to 1. So it follows that a raised to 7 over a raised to 7, that is equal to 1. Here, it is a proof that a raised to 0 is equal to 1. So bear in our mind, if a number or an expression is raised to 0, that is equal to 1. Let's have some of the examples. 10 raised to 0, that is equal to 1. Another one. 5 raised to 0, x to the 4th. Again, 5 here is raised to 0, that value is equal to 1. Then we'll copy x to the fourth. So simplifying this expression, that is equal to x to the fourth. And quantity 2, x to the sixth, y to the fourth, raised to 0. The whole expression is raised to 0, therefore, the result will be equal to 1. Let's also discuss negative exponent. In general, for any non-zero number a and any integer n, a raised to negative n can be written as 1 over a raised to the nth power. Let's have an example. A squared over a to the fifth, applying the quotient of powers, that is a raised to 2 minus 5, then the result is a raised to negative 3. But if we will utilize this format, a squared over a to the fifth, that is equal to 1 over a to the fifth minus 2. So here, the value of our expression is 1 over a cubed. Here, it is a proof that a raised to negative 3 can be written as 1 over a cubed. Let's have an additional example. X raised to negative 6 can be written as 1 over x to the sixth power. And quantity 2, x to the sixth, y to the fourth raised to negative 1 can be written as 1 over quantity 2x to the sixth, y to the fourth. So this is how to write our expressions with negative exponent. Let's also simplify exponential expression. But remember this one. An exponential expressions are said to be in simplest form if and only if. First, all the exponents are positive. Second, there are no powers of powers. Third, each base appears only once. And all fractions are in simplest form. With this, let's simplify exponential expressions. First, 6 raised to 7 over 6 raised to the fifth power using the quotient of powers, that is 6 to the 7th minus 5. The result is 6 squared. And 6 squared is an exponential form that can be simplified as 36. Another one, d squared times 3d to the sixth power. In this case, all we need to do is to add the exponents of d. So our simplified form is 3d to the 8th power. Another example, quantity m to the 9th power raised to the 5th power. All we need to do is to multiply 9 and 5. The simplified expression is m raised to the 45th power. Let us simplify quantity 9r as raised to the 2nd power. Here it can be written as 9 squared r squared s squared, and the simplified expression is 81 r squared s squared. Let's simplify quantity 2x raised to negative 6 y raised to 0 raised to the 4th power. Applying the concept of power of a product, all we need to do is to multiply the exponent outside the grouping symbol to the exponents present inside our grouping symbol. That is 2 raised to 1 times 4, x raised to negative 6 times 4, y raised to 0 times 4. The simplified expression becomes 2 to the 4th, x raised to negative 24, y raised to 0. So 2 to the 4th can be written as 16. In this case, x raised to negative 24 can be written in terms of an expression with positive exponent, and that is 1 over x to the 24th power, while y raised to 0 is equal to 1. Then, to write this in simplified form, that is 16 over x to the 24th power. This time, it is your turn. Simplify the following exponential expression. First, 2 raised to 8 over 2 raised to the 5th power. Second, 7n cubed times 5n to the 6th power. Third, quantity of negative 2p to the 4th raised to the 5th power. Fourth, quantity of 5x raised to negative 4, y raised to the 6th power raised to 0. Quantity 4, d cubed, e raised to 0, f raised to negative 2. And the sixth one, x raised to negative 10 over y raised to negative 5. So make sure to apply the different laws of exponents in simplifying this exponential expression. There you have it. Hope you learned something new today. God bless us all.